Welcome, tech fans. Whether you're a seasoned PC builder or just starting to explore the world of computers, you're in the right place. Today, we're diving into the heart of your PC's visual power, the graphics card, or GPU. This is the part of your computer that brings your digital worlds to life, making everything from games to creative projects look stunning. The GPU is the component that transforms lines of code into the breathtaking visuals you see in your favorite games, powers smooth video editing, and even helps train artificial intelligence models. It's the unsung hero behind every pixel in animation. But GPUs do so much more than just make games look good. They accelerate scientific research, help create digital art, and even drive technologies like virtual reality and cryptocurrency mining. In this chapter, we'll break down what makes GPUs tick, why they matter so much, and how they shape your entire digital experience. We'll peek inside to see how all those tiny parts work together to deliver incredible performance. Think of your computer as a team. The CPU is the manager, organizing tasks and keeping things running smoothly, while the GPU is the artist, painting millions of pixels every second to create vibrant images and fluid motion. Understanding GPUs helps you make smarter choices when building or upgrading your rig. Knowing what to look for can mean the difference between a good experience and a truly amazing one. Whether you're a hardcore gamer chasing the highest frame rates, a digital artist seeking color accuracy, or just curious about how your computer works, this deep dive is for you. There's something here for everyone. We'll compare GPUs to CPUs, explore their key components, and follow a single frame's journey from raw code to the vibrant images on your screen. You'll see how each part plays a crucial role in the process. Plus, we'll touch on essential topics like cooling, drivers, and the latest tech that keeps your GPU running at its best, ensuring you get the most out of your hardware for years to come. So grab a drink, get comfortable, and let's get started on this exciting journey into the world of GPUs. To understand GPUs, let's start with the CPU, the brain of your computer, handling everything from your OS to complex tasks. CPUs have a few powerful cores, perfect for sequential complex work like AI or spreadsheets. In contrast, GPUs are built for parallel processing with thousands of smaller cores working together. Imagine painting a million dots. A CPU does it one by one, while a GPU does them all at once. That's why GPUs excel at graphics, calculating millions of pixels, dozens of times per second. The CPU directs the action, but the GPU handles the heavy lifting of drawing and rendering. For modern games and high-res displays, this partnership is essential. The CPU figures out what needs to be drawn, the GPU makes it happen fast. Neither is better, they're just built for different jobs. The result? Smooth, immersive visuals and responsive gameplay. That's the magic of CPU and GPU teamwork. Let's see what's inside a GPU that makes this possible. Inside your GPU, the real stars are the cores, thousands of them called CUDA cores if you're using an NVIDIA card, or stream processors if you're on AMD. These tiny processing units are the muscle behind every frame you see on your screen, working together in massive parallel to crunch numbers at lightning speed. Each core is like a miniature worker handling a small piece of the overall graphics puzzle. The more cores your GPU has, the more calculations it can perform at the same time. This means smoother gameplay, faster rendering, and the ability to handle more complex visual effects. It's like having a huge team of workers, all tackling different tasks at once, making sure your games and creative projects run seamlessly. But those cores can't do their job alone. They need a constant stream of data to work with, and that's where VRAM comes in. VRAM, or video RAM, acts as the high-speed workspace for your GPU, feeding it the information it needs without delay. VRAM is a special type of super-fast memory built right onto the graphics card. It stores all the textures, 3D models, frame buffers, and assets your GPU needs to access instantly. The more VRAM you have, the more detailed and complex your scenes can be, especially at higher resolutions or with demanding games. If you run out of VRAM, your GPU has to reach out to your system's much slower RAM, causing stuttering, lag, and long load times. This is why having enough VRAM is crucial for a smooth experience, especially in modern games or when working with large creative projects. The rendering pipeline inside your GPU is like a high-tech factory assembly line. Data flows through a series of specialized stages: geometry processing, texture mapping, lighting calculations, and more. Each stage is handled by dedicated hardware, ensuring every detail is processed efficiently and accurately. The ultimate goal is to keep every single core busy every second so nothing goes to waste. When all the cores are working in harmony, your GPU can deliver stunning visuals and smooth performance. Modern GPUs are incredibly complex machines. Beyond just cores and VRAM, they include schedulers to manage tasks, memory controllers to handle data flow, and even dedicated units for advanced features like real-time ray tracing or AI-powered effects. All these components work together to push the boundaries of what's possible in graphics. It's all about efficiency and speed, making sure every part of the GPU is optimized to deliver the best possible performance, whether you're gaming, editing videos, or exploring virtual worlds. The architecture is designed to process massive amounts of visual data in parallel, allowing your GPU to handle everything from simple 2D images to complex 3D environments with ease. That's why GPUs are so powerful, not just for gaming but also for content creation, scientific simulations, and even artificial intelligence. Their ability to process huge amounts of data in parallel makes them essential for a wide range of tasks. Next, let's see how all these parts, cores, VRAM, controllers, and more, work together in perfect sync to create the images you see on your screen. Time to follow a frame's journey through the heart of your graphics card. Let's pull back the curtain on how your computer turns lines of code into the stunning graphics you see on your screen. It all starts with the CPU, the brain of your computer, which gathers up all the information about the scene. 3D models, their positions, the way the lights are set up, and even the camera's point of view. The CPU then sends this bundle of scene data over to the GPU, the graphics powerhouse, which is specially designed to handle the heavy lifting of turning data into images. The first stop for this data is the vertex shader. Think of it as a master choreographer, transforming every 3D point, called a vertex, into its perfect spot on your 2D screen. It takes into account the camera angle, perspective, and even how objects move, setting the stage for everything you'll see in the final image. Next comes rasterization, a process that breaks down those 3D shapes into flat triangles and figures out exactly which pixels on your screen each triangle covers. It's like creating a digital coloring book, outlining every shape so the next stage knows where to fill in the details. Now, the fragment shader, or pixel shader, steps in. This is where the real artistry happens. For every single pixel inside those triangle outlines, the shader decides what color it should be. It applies textures, calculates how light and shadow play across surfaces, and adds special effects like reflections or glow, making the scene look rich and lifelike. Here's where the GPU's true strength shines. With thousands of tiny processors working in parallel, it can handle millions of pixels at once, repeating this process dozens of times every second. This parallel power is what makes modern graphics so fast and detailed. Once all the pixels are colored and effects are applied, the finished image is stored in a special memory area called the frame buffer. This is like a digital canvas, holding the completed picture until it's ready to be shown on your monitor. While you're looking at one frame, the GPU is already hard at work building the next one, ensuring a seamless flow of images for smooth animation and gameplay. Amazingly, this entire process, from raw data to finished image, happens in just a few milliseconds, over and over, creating the illusion of motion and bringing digital worlds to life right before your eyes. Every game you play, every video you watch, and every animation you enjoy relies on this incredible graphics pipeline, working tirelessly in the background. It's a technical marvel, running invisibly and efficiently every time you play, create, or simply watch something on your device. That's the magic behind every single pixel lighting up your screen, turning code into vibrant, moving images. But to keep this visual symphony running smoothly, your GPU needs more than just raw processing power. It needs the right support to stay cool and energized. So, let's dive into how cooling, power, and connections keep your graphics card performing at its best. A GPU is more than just a chip, it's a system. High performance means high heat, so cooling is critical. Heat sinks and fans pull heat away from the chip, keeping it cool and stable. Some enthusiasts use liquid cooling for even better results, but good air cooling works for most. GPUs also need lots of power, delivered through dedicated connectors from your power supply. A quality PSU is essential for stability and safety. On the back, you'll find HDMI and DisplayPort outputs. These send the finished image to your monitor. DisplayPort is best for high refresh rates and resolutions. HDMI is great for most setups. Some cards even have USB-C for modern displays. Every part, from cooling to ports, is designed to keep your GPU running at peak performance. Without these, even the fastest chip would fail. But there's one more piece you can't see: the driver. Let's see why it's so important. Your GPU needs a driver, a translator between your operating system and the hardware. Without it, your games won't run right, or at all. Drivers tell your PC what your card can do, and optimize how games use it. Updates often boost performance, fix bugs, and add features. Game developers and GPU makers work together to ensure new titles run smoothly from day one. Keeping drivers up to date is one of the easiest ways to improve performance and stability. Tools like GeForce Experience or AMD Adrenalin make updates and optimization simple. The right driver unlocks your GPU's full potential. Now let's look at how GPUs are changing the world beyond gaming. GPUs aren't just for gaming anymore. Their parallel power is perfect for AI, scientific research, and content creation. Training AI models, rendering videos, and 3D animation all run faster on GPUs. Software like Adobe Premiere and Blender use GPUs to speed up editing and rendering. Even cryptocurrency mining relies on GPUs for their efficiency in solving complex puzzles. This demand has driven innovation, and sometimes shortages, in the GPU market. The GPU's versatility is transforming industries far beyond graphics. Let's see how they're shaping our digital world. GPUs have evolved from gaming gear to engines of modern computing. They power everything from movie effects and medical imaging to AI assistants and scientific breakthroughs. Their ability to process massive data in parallel is driving the AI revolution and solving problems once thought impossible. For individuals, GPUs enable creativity, community, and access to supercomputing power at home. They democratize high-performance computing, making it accessible to everyone. Every frame you see is a testament to this technology's impact. The graphics card is more than hardware. It's a catalyst for innovation and imagination. And the journey is just beginning. The future of GPUs is brighter than ever, with fierce competition driving rapid innovation. Expect more efficient designs, better AI integration, and even more realistic graphics. Gaming and professional uses will keep merging, unlocking new possibilities for everyone. The community